Hello again, back in the workshop today, and today we're going to talk a little bit about archaeology, or industrial archaeology to be absolutely precise. Basically, when I talked about this project, when you take on something where somebody else has been before you, certainly to the extent that this engine, the D49, has been progressed, there's a certain or large degree of trying to find out what has gone before, what needs reworking, and what approach has been taken, what changes have been made between the drawings and the design and what you have in front of you, and also where you want to take it. So yesterday I spent almost a complete day poring over the drawings in order to make some materials purchases. What I was doing principally was looking at valve gear, and on the basis that actually getting model engineer's laser to cut the rods and links costs very, very little more, if anything, than buying the raw material, particularly if you've taken into account the amount of waste material you're going to have that you're cutting away from it. So I made as an extensive order as I can with model engineer's laser. They haven't actually done the gear or rods for this before, so it's a new thing for them. So I did extracts from the drawings to understand what bits I needed and what sizes and everything. And that necessitated quite a close look at the drawings overall, and further thinking about what I have in front of me and where we are going to take it. So two things we're going to look at first is the valve area of the piston castings and the cross beam for the 2-to-1 levers for the derived motion of the center valve. So some of it's going to be handheld, so it's going to be a bit shaky, but let's go through what my consideration is and what the drawings say. So just a quick overview to remind us where we are. The front bogie is back on for now, and the whole thing is sitting now on track, level and even, and rolling back and forth quite happily. So we're in a reasonably good place. So things we're going to look at particularly today are the valve chests, the valves, and also the 2-to-1 bracket, because something has come interesting about that. So we'll come back to that in a minute. So let's look at the drawings and see what we should be seeing. So looking inside here, we are seeing ports that don't quite seem to correspond with anything. Interesting. So we have 4 ports down the front, 4 ports at the back, and another 4 ports. So I think we need to do some dimensional investigation to see how those match to anything else. So that is what's going there. Now, as I come out, there is a sleeve there. Okay, so we can see the ring of the sleeve in the block. So what we've now got is something that is probably what it should be if the ports all go to the right place. However, the dimensions are not quite as per drawing. Can we live with that? I think we'll have to wait and find out. This is just a short clip from the boroscope camera to give you an idea of what you actually see while you were using it. It is very difficult to keep it still, and even if you've got it tied down to something, the end of the thing will wobble a bit anyway. But that's what I was looking at when I was trying to do this for you. So the next part to look at is the bobbin itself. Definitely not quite as drawn. So let's have a look, see So we decided that the diameter is not correct. It's 3/4 inch, which is 12/16. Length of it, two and a quarter. That's fine. The distance between the backs of the heads, 1 5/8. That's not so fine. That's definitely not so fine. So these heads are much thicker than shown on the drawing. That is going to be an interesting question as to how to deal with that. We know there's been changes made to the design of the sleeve. So the question basically is, has this been modified along the lines of what we found in the sleeve? Next question, I think, is to try and find some dimensions for where those ports sit compared to where we are just now. Okay, so what I've now done is I've set up the endoscope, clipped it to the valve gear rod, and tried to get it more or less centered to the valve sleeve. What I'm going to do, or what I'm trying to go and do now, is to use the guessing stick to measure where ports are as far as we can. I've determined that the overall length internally is 3 45/64. So what I'll just do is I'll measure from this side and just see where we get to when we start pushing this thing in and getting the ports. Okay, with a bit of setup time, what I'm going to do now is try and get some dimensions for the ports as they sit at the moment. So what I've done is I've set up the camera right above the cylinder. I've got my trusty guessing stick set up to do fractional measurement, because that seems to be what we're working in on the drawings. The endoscope is pointing in the far end of the cylinder. I've taken the front cover off, which is very simple, very much just a plug, and it's held in just by one screw. Now that shouldn't be a challenge, though there's nothing determining how those should fix in the drawings. All they are doing is closing an end, because theoretically there's not much steam pressure there, or at least there shouldn't be, providing the bobbin is not leaking. If it leaks, then there will be pressure there, and with consequence we'll get the ends blown off the cylinders, but off the valve chest. I don't expect that to happen. So let's get started anyway. The first dimension I want to get is the overall length of the cylinder itself. So I'll just push the guessing stick down until I can see it at the other end. Oops, and then bring it back. Let's get something to put that up with. So that is flush there. 3 15/16 overall. So the next dimension I want to get is to the first port from here. And that is going to be done fairly visually. That seems to be 47/128. Not a regular, it's not quite. Let's try again. Yeah, 47/128. go to the other side of that so we can get an idea of the diameter of the hole we have to play with. Just try and catch the edge of it. And that is 71 1/2/8. Now keep measuring from the same point. We should be in better shape, but it's not going to be so easy to measure those. Let's see any better on the scope here. All right. There. It's got oily. Okay, off camera I'm going to work backwards the other way now and get dimensions from the other end and see if that makes any difference to what I'm showing. I've taken the dimensions I've abstracted from the cylinders and put them on this drawing, and below that I have drawn out the bit from Clarkson's drawing to show exactly how things are lining up. It seems the ports more or less line up, and the diameters are roughly equivalent to the widths on the other ports. However, as the ports is drawn as square and these are round, there's a very significant difference between the open areas, as you can see from the port areas on the diagram. So I need to speak to somebody else and figure out what to do next with this one. So the next bit of archaeology today is this here. This is the cross member, which is responsible for holding the 2-to-1 gear. Now I must admit that when I first got these drawings, the whole situation with the pivot point of that left me somewhat concerned. The drawings do not at any event give a dimension for that. They also don't give that precise a dimension relative to any other part of the framework for the exact final position of this either. So I mean, there's no dimension from anywhere to anywhere. So what I'm just going to do is just take a couple of dimensions as far as I can, scaled off the drawing from the plan, basically to that flange there seems to be a good starting point. Let's just see where that is. So we're going to take a dimension off the drawing, which is to the center line is 2 39/64. Should be from the center to the face of that block. Well, I think within the accuracy of the scaling off the drawings, I think that's actually not in too bad a position. What I do want to change for this is the way it is bolted to the frames. It seems there's quite a lot of wrong size nuts and bolts compared to the drawing, because it's called out all in 4BA, and these are 6BA at the moment. So, and the drawing says 4BA countersunk. These are 6BA currently hex heads, because I put them in just to hold them in position. The bolting pattern again, compared to this, is completely wrong. So it'll be 4 across the top and 2 in the bottom and 2 down each side. Instead we've got 3 across the top, missing on the left hand side. But also, from an archaeological perspective, if we look closely at what we've got here, there have clearly been some other holes there that have been filled in. So quite what happened, I don't know. I don't know how I'm going to tackle this yet. This is going to not be today's further task. It needs further consideration. But in reality, what we are going to be exploring is filling in some of the holes that are in the wrong place, both in the beam itself and in the frames, and drilling some new holes, which is going to be quite an exercise, because the best place to drill them would be on the mill. But trying to get this in enough pieces in order to be able to set the frames on the mill is going to be quite a challenge. So again, something that needs to be looked at. Now, the other significant question I've got about this beam at the moment is, as I was going through the Clarkson's catalogue for parts order for this, what I discovered was that this beam should be cast iron, according to Clarkson's catalogue and according to what is supplied today. This one most definitely is not. You can just about see in the holes there that it's quite brassy. So, or you can see as well on the below the pin there, it's definitely, you know, bronze or gunmetal or something other than cast iron. Not sure that's a problem. It's just a question as to whether this piece actually belongs to this engine at all, or whether it's come off another Gresley 5-inch gauge model. I mean, there's quite a few about. It's not dissimilar to what you might find on an A3 or an A4 or a B17, all of which have parts and castings available for them. One further question I have is what should happen here. This is the back of the center valve chest. Clearly there's screws in the top and possibly in the bottom to provide a cover. In the parts list from Clarkson's, there isn't a casting for that as such. For these ones, there is a casting. It's quite long and it takes a little crosshead device. Whether there should be one on the center, I don't know. Whether the ones that are provided for the outside could be adapted to the central position, I also don't know. But again, that was on my order this morning to Blackgate, so I'll have the castings to look for these ones, which, given the dimensions we've got here today, are going to have to get modified as well. And see if it looks like I could try and get another single casting and do that. Also, in the list of not quite correctly done things, this is the boss for the valve gear. These again have 4 screws of the wrong size in them instead of 3 screws. Getting these out is going to be quite difficult because the heads are actually colliding. Now, quite what the thinking was behind doing that, I don't know. Again, it is likely to be something I would want to modify in time, but whether that is going to happen sooner or later, I don't know. At this point, I'm more interested in getting the main bits done and the main stretchers done. So, as you can see, the pump stretcher is missing, again ordered. And the other thing that might become a challenge for today is there is another stretcher here. This stretcher is predominantly part of the braking. It holds the brake cylinder. Now that random hole there isn't quite in the right place, and I don't know quite what it's for because it doesn't quite appear on the drawings as such. So that may be a position I can use to start fixing that crossbeam in. The proper Clarkson's version has a cylinder for a brake cylinder actually cast into it, and it looks quite a fearsome thing. As it happens, I already have a brake cylinder to hand. I took it off my King Scale Austerity because having a steam brake on a shunting engine is not that much use. A handbrake was much more useful, so I made a handbrake for it, kept all the linkages and everything, and took off the steam cylinder, the valve, and the other bits related to that, which will work on this, I believe. once I've figured out what this beam here looks like and how it would pick up the cylinder, then I can figure out quite where that is going, and if the travel in the cylinder I have is close enough to the travel in the Clarkson design, then I'm golden. If not, I will have to rejig some of the lever arrangements that go on this bar at the bottom here, in order to get the right sort of movement in the wheels. That's probably another day, or it might be later today that I start working on that. So these are the brake parts that have come off my austerity. I've got the valve here, which is similar in intent to the drawing there, which I think is twice size. And the cylinder, again, that's the twice size drawing there, which is also similar. There's probably more movement on this one than is shown in this drawing. I'll measure it up exactly. It does look like I need to change the actuating rod somewhat, and get a bit of an understanding. I mean, this is all sealed. The Clarkson one looks like it has an adjuster on it. I'm not quite sure how that works from here. I mean, there's a better GA of it there. Still not quite sure how it works yet. In principle, it's the same thing. Basically, this is pushed downwards. This is pushed downwards by steam pressure that comes from up here, which comes from the valve there. Dimensionally, it's not far off, so I'm going to give it a go and try and modify the design of this here, which is the beam that this sits on. That's in section, to take this. So that's going to be the next little drawing challenge, and I'll maybe cut some metal on this, because it's nice when you're in the workshop to actually make something proper. There we go. Basically, I had a piece of steel rather than use a casting, because the casting has the cylinder which I'm not using. So I cut the steel to size and changed dimensions slightly. It's a bit narrower than it is in this drawing, but the cylinder doesn't require the second fixing point. It just sits in one place. So now what I've got to is I have got the bracket on the mill, and I'm just about to start cutting the holes for the to fix the cylinder onto it. So here's the setup. What I've done is I've put 1/2-inch holes through everything already. The 3 on one side are going to get turned into that oval slot for lightning, I presume. The one on the left is centered on the new cylinder position. What I need to do is to go around that and create 6 fixing holes in a circular pattern. So I started showing this the other day on the DRO, but here is the method of setting out the pattern, and this is the pattern I want on the DRO. So I exit that just now, go back to here. So starting with 0, 0, which is where the drill is that went through to make the 1/2-inch hole. And my radius is 0.545. I have 6 holes to make, and I want them, the arrangement aligned along the axis of the piece of metal, so that the 2 edge screws are as far inboard as possible. So if we hit run now, what we have is a starting point, and we can just go through and check each point. So what I'm going to do is go to the other camera and watch me doing that on the actual piece of work. So back to setup in the vise. What I've got is a sensitive chuck here. I'm going to be using very small drills, and it's a bit of a big brute to start using the thing with the quill as it is. So I'm going to certainly go around now and mark out what's going on. So before I will drill anything, what I'm going to do is follow the DRO's instructions and make sure that the points are landing where I think they're going to land approximately. So the first instruction is X545, which is our radius. So if I go 545, I go back to 0 on the DRO, that should land me exactly where I need to be. Okay, so that's landing there. That looks right to me. Let's go to the second point. That is back 2693. And back to 0 on the Y. Yes, that's going to be quite tight to the edge, but that should still be fine. Next one should just be a translation in X of 54452. Yeah, you can run quite quick on the X until you get close to the numbers, then just try and wind it in. We're doing that. Okay, drop that down. That's about right. Next one. So basically there. Again, that looks good. Let's check they're not too close to the edge on the other side. So that is Y-axis dialed in, X-axis dialed in. We're trying to get it to the nearest thou. No point in being any more accurate than that because that's as good as it is. So right, yeah, all those points are good. Right, I'm going to start drilling now. I will actually stop for a minute and change the speed because I slowed the speed down to 355 for the half-inch drill. I want to get it back up to 650, I think, for the smaller drills. So the one disadvantage of this machine is that the speeds are a bit gappy. I've got nothing between 650 RPM and 1430 RPM, which is just too big a gap. I'd rather be doing this at 800 or 900, but let's see how it cuts at 650 anyway. Otherwise I have to put it up to 1430. Okay, changed my mind on this. At risk of breaking that off, I'm going to use the quill because I just need to put a bit more force than I can possibly do with that. I can go back to that when I start drilling. So let's, oopsie daisy, right. Let's have a go with this and see what happens. So moving along now, translate 54472. next one, translate X and Y 27334. What I'm doing is I'm watching the positive negative indicator to change and then slowing down and resetting from there. It's the quickest way of doing it. So you overshoot by about 20 or 30 power by doing that, but it's quicker I think than doing it the other way. Right, let's try this. So I'm going to put a wee bit of gunge on the end, on the end of the drill. Running out of this stuff. This is one of my favourite go-tos, moly-slip metalworking fluid. I've got another pot of it when this one runs out, but I'm not going to miss the last few mil of it, to be honest. Right, so that's centre drill in all the holes. Now I'll just get the right size drill. And what I've decided to do is go for a clearance drill. So what I'm using is a number 38 drill, which is just a little bit larger than we need to have. But I don't have to lift this to get it in. But so it's giving me about 1/10 of a millimetre extra clearance, which I think is helpful. Where's me gunge gone? There it is. There's a little bit more metalworking fluid on the drill. Great, off we go again. So we're on the first hole. Brilliant. So that's it. Now I need to just get the mill through that to make that a nice simple pattern. I'm keeping on 650 and put in a 3/8 inch mill. I'm just going to try and chunk through this. This time I'm using this stuff, multi-purpose cutting oil, which it seems to work all right for this sort of thing. We're not going fast enough or using tools that really need flood cooling, and it's a big mess in this workshop anyway. So let's just go at this and see what happens. I'm sorry I lost the other camera halfway through that cutting operation. It's all very simple, just a couple of passes with that mill and we are done. So let's take it out the vise and offer it up to the parts that it's going to go with. So there it is, a long afternoon's work, chunking that out for a bit of steel that looked like this to start with. Yeah, quite a lot of mill work today. So the cylinder's on and screwed up. This is probably not the piece of pipe that will be used with it ultimately, but I just wanted to check that, make sure there's enough clearance in there for that to fit. So all the screws are well inboard at the edges. Yeah, the lighting hole's done and cleaned up. What I haven't done yet is drilled any holes in the ends where it fits the chassis. So eventually it'll sit in somewhere around here, but in order to make sure all the holes line up properly, this is going to have to wait until I can get the chassis on the mill bench, as I said, and I will basically clamp that in. Well, what I'll do is I'll get the center holes done, clamp it in or bolt it in, and then drill the outside holes. Now it's going to be interesting, I think, because it is behind the wheels and there's not much space there. So we'll probably have to use countersunk screws to fix that in. Anyway, that's another job done, and that's all my scribblings in the book, which basically gives me all dimensions I was working to, and a sketch of what I actually wanted to make, which is different from what was on the main drawings. Important, keep good records. Anyway, that's it for this, and see you next time.